Okay, hi. We're going to start this session talking about briefly about functions and difference quotients, and then we're going to go to linear function. The difference of quotients, we're going to use this. F of x plus h minus f of x over h. H is not equal to 0. This is what we call the difference quotients. Especially for those of you who are going to take pre-calc and calc, this is the groundwork for you to think about slopes of different equations. Okay, so we're going to start with this. So basically what we're going to do now is, I'm going to give you an example. If f of x is equal to 2x squared minus x plus 3, and you are asked to find the difference quotients, meaning what? You are going to plug this into this. In other words, it's also making us think what is the slope of f of x is equal to 2x squared minus x plus 3. That's what we mean by difference quotients. Okay? So let's do that. For the first one, you're going to do what? So you are going to replace x plus h into this equation. So wherever there is x, you're going to put x plus h. So you do f of x, probably you need to do it one at a time. What is f of x plus h? So you're going to do 2, instead of x, it becomes x plus h squared minus, again, instead of x, you put x plus h plus c. And let's simplify this. This is, don't distribute 2 yet. Okay, expand this. This is x squared plus 2hx plus h squared. Okay, then minus x plus h plus 3. Let's go ahead and simplify this again. So this becomes 2x squared plus 4hx plus 2h squared. Let's distribute the minus sign. So this is minus x minus h plus c. Okay. And probably let's see, there is nothing that we can actually simplify. So this becomes your f of x plus h. Your f of x is 2x squared minus x plus 3. So what we're going to do with this would be what? We are going to subtract this f of x from this and divide it by h. And then that's how we can find the slope or the difference quotients. So you're going to do what? Put 2x squared plus 4hx plus 2h squared minus x minus h plus 3 minus the entire thing, 2x squared minus x plus 3 over h, and h is not equal to 0. So we're going to do, so we are going to simplify this. 2x squared minus 2x squared, they cancel out. Bring 4hx plus 2h squared minus x minus minus x, they cancel out. Bring minus h, and the 3 also cancel out. 3 minus 3 is 0 over h. Okay. Now, let's simplify this. So we're going to do what? Take h out. So you have 4x plus 2h minus 1 over h. And then you take away h from each side. So you have the difference quotient of this function is 4x plus 2h minus 1. In other words, the slope. Okay? So that h is not equal to 0. Okay? All right. And then I'm going to give you an example. So the new thing about this is the f of x plus h, and I know how you can do this for the assignments. Okay? So now, what we will be talking about is linear function. All linear equations are functions because they are one-to-one. Meaning what? For one value of x, we get exactly one value of y. Okay, that's what makes it a function. Okay, so you know the concept of the slope in a linear function. It is quite easy, which is rise over run, or the ratio between the difference of y2, the difference of y, over the difference of x, as long as x2 is not equal to x1. Okay, so this is basically the idea behind describing a linear function. Okay. So let's use this definition of the slope and to figure out. I'm going to give you like one or two examples. So you have a pair of points. -3, 4, and -4 and -2. And we are asked to find the slope. You know, these are ordered pairs. This is x1, y1, then x2, and y2. So go ahead and apply the definition. So this is what? -2, -4, over -4 minus -3. And -2 minus 4 is -6. And -4 minus -3 is -4 plus 3, which is what? -1. And the slope is 6. Okay? Or 6 over 1. Okay? This is the rise. For each 6 units towards the y-axis, x moves 1 unit towards the right axis, the x-axis, or horizontal. Okay? So this is basically what we do for if you have a pair of points to find the slope. Okay. Probably let me do another one. And 4 and -2 and -1 and 5. Again, go ahead and find the slope. Label them x1, y1, x2, y2. So you have what? 5 minus -2, right? Over -1 minus 4. Okay. So 5 minus -2 gives you 7. And -1 minus 4 gives you -5. So you could rewrite it 7 over -5, or you can write it -7 over 5. Okay, you can assign the negative number for either x or y. But what it tells you is, if the movement of y is 7 units upwards, the movement of x is 5 units to the left. If the movement of the x-axis, if the y-axis is 7 units downwards, then the movement of x is 5 units to the right. So that is basically what we're talking about. So in our two examples, we saw one of them is a positive slope and the other one is a negative slope. One way of determining whether the slope is negative or positive is by just the graphs. So if you have a graph starting from quadrant 3 and crosses across quadrant 2, or it's going upward, this is going upward, so this is the slope is positive. Okay. But if it starts for quadrant, if it covers quadrant 2 and quadrant 4, this is a linear function going downwards, so its slope is negative. One is positive and the other one is negative. Probably we need to add two more concepts of the slope. If you see a slope and if the graph is a horizontal line, what we are saying is there is no movement on the y-axis. So if you apply the definition, so you would end up with 0 over some number of x. And if that is the case, then the slope, because the numerator is 0 and the denominator is some number, the slope has to be 0. So you would say the slope is 0. If you have a graph that is moving up and down and not sideways, then if you can plug in a number, you would end up with the denominator 0. You know, anything over 0 is undefined, so therefore the slope of the vertical line is undefined. So if we know these four distinct concepts, then we are okay about talking about linear functions. Okay. There are many ways to find the slope and to graph the function once we find the slope. Okay. Let's first talk about the point slope form of linear function. And the point slope form derives from our formula of the slope y2 minus y1 minus y1 over x2 minus x1 is equal to m. The slope is the ratio of the difference of the two. So if I do cross multiplication, what I'm going to do would be, I'm going to multiply this by this, y2 minus y1 times 1 is equal to m times x2 minus x1 by cross multiplication. And this would be y2 minus y1 is equal to m times x2 minus x1. This is basically how it looks, how the point slope formula looks like. The only difference is we can take this out, the 2 out, because you are writing an equation. Y minus y1 is equal to m times x minus x1 is the point slope form of linear equation. So we are going to use this formula to write an equation. Okay. So let me write it again. Start. Write an equation of a line. Passing through -1 and 3, and the slope is this line. So when you see this, it is much better to use the point slope form. There are other equations that you can also look into. So this is, because it passes through -1 and 3, we can do x1, y1, and then the slope is n. Okay, so once we label it, then we say y minus y1 is equal to n times x minus x1. Okay, apply this. Then go ahead, y minus 3 is equal to, the slope is 4, and then you have x minus your x1, which is -1. So what do we get here? Y minus 3 is equal to 4 times x plus 1. Y minus 3 is equal to 4x plus 4. You wrote the equation in the form of point slope form, but you would be asked to write it in a slope intercept form, which is quite easy. Isolate y by itself. So you add y plus 3 plus 3. So you have y is equal to 4x plus 7. This is what we call slope intercept form. We choose this equation because it gives us what? It gives us explicitly what our intercept is, which is what? 7, meaning what? When x is 0, y 7. This is our y intercept. Okay. Because you can see it from the equation if you write with the slope intercept. Okay. Again, another example of writing an equation. This time, the line is passing through the points. Let's look at that. 4 and -3, and -2 and 6. Okay. Now, mind you, in this example, the slope is not given to us. And before we write an equation, we have to find the slope. So go ahead and use the definition of the slope, y2 minus y1 over x2 minus x1. You know this one is your x1, y1, x2, and y2. So y2 minus y1 gives us 6 minus -3 over, and then x2 minus x1 is -2 minus 4. Let's go ahead and simplify this. 6 minus -3 is 6 plus 3, which is 9, and -2 minus 4 is -6. So you have a negative slope. And by the way, so it is what? A graph that is descending. Let's just simplify this, so you end up with -3 over 2, which is your slope. This is what you need in order to write an equation. At this juncture, you don't need both pair of points to write an equation. So get rid of this because you already found the slope. You can get rid of either of them. So you have to use now the point slope form, m times x minus x1. So yeah, now your y1 is -3, so y minus -3 is equal to, your slope is -3 over 2, -3 over 2, and x minus 4. Simplify this. This would be y plus 3 is equal to -3 over 2x. Negative times negative is plus. And you end up with 12 over 2 or 6, right? Or 6. Okay. Don't stop there. Go ahead and write it in a slope-intercept form. All you need to do is what? Move 3 to the other side. Minus 3, minus 3. Then y is equal to negative 3 over 2x plus 3. Your y-intercept is 3. Your slope is negative 3 over 2. And we're done writing that equation. Okay? So I'm sure you have seen this in your online 5 class. Okay. Now, how about graphing a linear function? Suppose you have f of x is equal to our earlier exercise, negative 3 over 2x plus 2. We want to graph this. You need 2 pair of points. So meaning what? You can choose any number from the number line. But there are convenient numbers that we can use so that we can make our life a little bit easier. If you let x is equal to 0, this entire thing becomes 0, and then y is equal to 2. That's why we call this other y-intercept. So your y-intercept is 0 and 2. This is one ordered pair that we need in order to do the graphing. And the second number that you can use is, if you want to avoid a fraction, multiply, because you have a denominator 2, if you multiply it by any even number, by 2, by 4, by 6, by 8, you get rid of the fraction. So probably the easier one is let x is equal to 2. If you do that, then this becomes f of x becomes negative 3 over 2 times 2 plus 2, right? Then 2 and 2 cancel out. So you end up with what? Negative 3 plus 2, which is negative 1. So if your x is 2, your y is, or your f of x is negative 1. It's only the 2 that you need in order to do the graph. So go ahead, you're going to sketch. Go ahead, your 0 and 2 is right here. Right? And then your 2 and negative 1 is somewhere around here. Okay, it's in the 4th quadrant. So you have 2 and negative 1. Then go ahead and draw a graph. And that is the graph of f of x is equal to negative 3 over 2x plus 2. Because the slope is negative, look at how the graph looks like. It corresponds descending from top to bottom. Okay. Let me do another one. How about f of x is equal to 3 over 5x plus 1. And in this function, we expect what? A graph that is rising because the slope is positive. But first, let's say let x is equal to 0. Then if x is 0, you have 0 and 1 as your y-intercept. And let x is equal to 5. If x is equal to 5, 3 over 5 times 5 is 3, and 3 plus 1 is 4. Then you have 5 and 4. Go ahead and sketch the graph. 0 and 1 is somewhere here. 5 and 4. So we have, what do we have here? Okay. So 5 and 4 is